Okay, so I've got two further examples here that just show you some other kinds of things you could get asked about, but I think you should find these pretty straightforward. So this question says, prove that the product of any two odd integers is always odd. Well, to begin with, we might just say, okay, well, an odd integer could be 2n plus 1. So what I'm going to do is I'm going to do that odd integer multiplied by this odd integer, and I want to try and show that this is always odd. Well, the trouble here is I haven't actually shown that this is any two odd integers. In fact, this integer and this integer, these two numbers, are exactly the same as each other because I've used the same letter. So for it to be two different odd integers, or possibly the same, but to give them the possibility of just being any two odd integers, I'm going to have to define two different ones. So what I'm going to do this time is I'm going to use the letter n and m. Let n and m be integers. So my two odd integers now are going to be 2n plus 1 and 2m plus 1. Do you see how the difference now with it being m and n, it allows it to be two different numbers. Now you don't have to pick n and m, you could pick a and b, or you could do c and k. Those are sort of the most common letters that people use for these things. But I'd say the top one is probably n and m, or k are the most common that people use. So what I'm going to do, as it says the product, that means something that is being multiplied. I'm going to expand this and try and show that it is always odd. So I'm going to have the 2n times 2m, which is going to be 4mn, do them in the order of the alphabet. Then I'm going to have the 2m times the 1, the 2n times the 1, and the 1 times the 1 that looks like this. Now, you might think, okay, well, how do I show that something is odd? Well, the way that I show that something is odd is I show that it's even, but with a plus 1 at the end of it. That's what I'm going to try and do to show that something is odd. So I'm going to look at these first three terms that we've got here, and I'm going to factorize those because I've got this nice plus 1 at the end. So to show that those are even, I'm going to take out a 2, which will be 2mn plus m plus n plus 1. Now this is probably enough to have explained this, but if you wanted to explain this in your proof, you could say this is even, hence becomes odd. You can annotate things like this if you want to. At the very end, you would want to then say, hence the product of any two odd integers, etc. You can't write down etc, by the way. I'm writing down etc just to speed up my videos, okay? So you should write down hence the product of any two odd integers is always odd because of this extra part that we've got here. This one is just kind of testing, can you do lots of stuff with algebra? It says, given that m is an integer, prove that the sum of a half m plus 1 and a half m plus 1 m plus 2 is always a square. So really we're just going to use that word sum, meaning we're going to add these things together, and we're just going to do a lot of algebra, and at the end we're going to hope that we can write it in a form where something has been squared as well. So I have a half m plus 1 plus, because we're doing the sum, a half m plus 1 m plus 2. So I'm going to do it on this next line so I've got enough space. So a half m times m, that's a half m squared, and a half m times 1 is a half m. So I've just done this part. Now, I'm not going to do the half, I'm actually going to do these double brackets first. So I'm going to put the half, and I'm going to do the double brackets inside a bracket. I'm just going to expand these bits. So that is going to be an m squared. See if we can do this a bit quicker. There'll be a plus m and plus 2m, which is 3m, and the 2 times the 1 is the 2. So that's a half m squared plus a half m from before. We have a half m squared. Now a half of 3m is 3 over 2m, because 3 times a half is 3 over 2, and a half times 2 is 1. Okay, looking kind of messy, but we've got here the half m squared and a half m squared. Well, a half plus a half is just 1, so we have 1m squared. Now I have a half m plus 3 over 2m. I have 1 half and 3 halves. 1 and 3 makes 4 halves. 4 halves is 4 over 2, which is just 2m. And then at the end, I have the plus 1. Now remember what we were even trying to do in this question. We were trying to show that it was always a square number. So I just need to take this expression and see if I can put it into this expression here. Well, we can do. If you factorize this, we're thinking of two numbers that multiply to 1 and add to 2. It's going to be an m plus 1 and an m plus 1, because 1 and 1 makes 2 and 1 times 1 makes 1. So you have m plus 1 squared. So we've shown that when you take these things and you sum them together, you always get a square number. So you would do your hence and then just repeat what they've said in the question. Now it's kind of cool. If you imagine just picking any integer here, let's just try it out and see that it actually works. Let's say something like, I don't know, m is equal to 5. Let's actually see if this works. It would be 1/2 times 5 times 6 plus 1/2 times this part here, 6 times 7. Let's see what this proof is even talking about. So this is 30 times 1/2, that's 15. And 6 times 7 is 42. Half of 42 is 21. And we get 36. Oh, cool. So we can actually see what this proof is saying. It's saying if you do this, you always get a square number, which kind of works, right? You can see that the algebra shows it, and here you can see with some numbers as well. This one's pretty obvious, right? You take two odd numbers, you multiply them, you get an odd number. I don't know, you could do 3 times 7, you get 21. You could do anything, any two odd numbers, and you always get an odd number. So I think these don't really feel that tricky, okay? I actually think these ones feel a lot more just doing algebra. Let's see, I'm going to do some trickier ones that have got some additional reasoning required on the next page, on the next video. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.